Hello friends, welcome to Unacademy and welcome to today's session. Hello friends, welcome. In this session, we are going to learn about a non-contiguous memory management system, another flavor known as segmentation. So, there are few varieties are there in non-contiguous memory management system. One is paging and the other variant is segmentation. So, what is the segmentation? And the segmentation further can be paged. So how to do that we are going to learn in this lecture. Why we are going for segmentation? Why not we are restricting and satisfying only with paging? Why segmentation is being used nowadays? So we are going to learn in this session. Before learning in this session, first let us say our anthem that crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's best educators. About myself, Srinivasarao Sir, having more than 15 years of experience in the GATE stream in CS. So many subjects I taught and I am teaching, and also had industry experience as a system analyst and a database admin. Throughout my journey of GATE, I taught in many premium academies with a high success rate, having many of the students are alumni of IITs, NITs, and central universities. And some of the students are also settled in topmost MNCs as a project leaders and system analysts too. So if you get admission in an academy or if you become a plus student, I can able to guide all these things to you also, as however I taught into my previous students. So there are two kinds of subscriptions are available in an academy. One is 12 months, the other one 24 months. So 12-month subscription, you are eligible. Fourth year students can able to opt for that. Those who are writing 2021 GATE examination, which is conducted by Mumbai IIT. If you got use my referral code to get the discounts and some kind of redeem points. If you get the subscription, you are going to become a premium member so that all the restrictions are being cleared. You can able to access whatever the contents are there as far as GATE and ESE platform concerned. And this is for third year subscription, and the second year students as well as third year students can opt this subscription. You're going to have many kind of recapitulation sessions as well as you also see that many live quizzes will be conducted and many doubts clearing sessions are also going to be conducted. Apart from that, I used to conduct quiz sessions on the different subjects and different topics. Therefore, please utilize this opportunity which is offering by Unacademy and use my referral code. On this referral code, you're going to get a good discount. So once you get the admission, you're eligible to learn the contents as far as campus interview also. So it is going to be benefited to campus interviews and your regular semester examinations as well as any kind of PSUs as well as GATE examination and NET examination concern. If you would like to interact with any kind of a faculty member, if you are having a doubts, that means what? Doubts in the class session or doubts in the guiding session, or if you are having any kind of a doubt, you can able to interact with the faculty member just by filling this form which are there in this link. So they are going to redirect it to you, the corresponding faculty member, so that you can directly interact with the particular person. So let's crack GATE CSC. Use my referral code, get the good amount of discount. Subscribe Unacademy YouTube channel, that's Let's Crack GATE CSC. Hit the bell icon for latest notifications. Friends, Now we will understand why we are leaving paging concept. This is very important. Why we are not stick it on paging concept, as paging is a non-contiguous memory allocation and paging is going to allow many kind of advantages, but why we are not sticking on to paging concept, why there is an enhancement required to this paging concept. There is a requirement of enhancement because page is a fixed size and the page is a concept is a what? Page is a suffering from internal fragmentation, especially you are going to see in the last page. Why? I will show you this example, you understand. I'm saying my process size. My process size is equal to 11 kilobyte and my page size or your frame size I'm saying as like 10 kilobytes. Now friends, you can understand how many pages you require. So I'm saying as per as a rule that number of pages are nothing but your 11 KB process divided by your 10 KB process. Hence you are going to require 2 pages. Please observe friend. These 2 pages, one page completely you are using how much? 10 KB, no doubt. This is a completely without wasting of a single byte or a bit information. It is completely occupied 10 kilobytes. And other page, if you observe, I do not have data. Only I have only the rest one KB only. Therefore, what is going to happen? This 1 KB is filled in the particular page too, and remaining you are going to see a concept of what? Fragmentation within that particular page. Hence, we are calling as that there may be a chance of internal fragmentation, especially in the last page where you are going to have some fractions. Now, this is one of the drawback. What is that? There may be a chance of what? Internal fragmentation in the last page, especially, and by default, we are assuming that n by 2 wastage is going to be happen, especially the last pages. That's why we are assuming that there may be a chance of half of we are going to see that wastage in the last slot. And the other important point why we are leaving your paging, this is another reason. What is that? Your paging is not going to be according to the user's point of view. What is according to user's point of view? If you understand that I am writing a one small piece of code, observe carefully. I am writing a .c file where you are having a main program and I am having some lines here int a and I am writing a loop here. A is equal to something like a 1 and a less than or equal to 10 and I am writing I plus plus. We want to see that printf a value %ld and a and close the braces. This is my program 1.c. Please observe carefully. Now, if I am saying that my page size, please understand. So there are 1, 2, 3, 4, 5, 6, 7, 8 lines are there. Line 1 and line 2 and line 3, line 4, line 5, line 6, line 7, 5, 6, 7 and line 8 lines of code I have. So number of lines in your code is 8. Now what I am telling you, I am assuming that let my page size is equal to 2 lines only. So when you are saying that your page size is equal to 2 lines, how your memory is going to be splitted, please observe carefully. In the first block, it is going to send 2 lines of information. That is nothing but main will reside there and delimiter is going to reside there. This is I am saying frame not, it is available. And immediately there is a one more slot. In that slot next 2 lines are being present. What are the 2 lines? I am taking this time int a and for loop. in this block. That means you see this is a frame 1 and this is a frame 2, and one more slot we have frame 3, and one more slot we have frame 4. As we know that the pages can be placed anywhere on the memory randomly. That is the advantage of paging. This is your first, which is linked to this as a linked organization. Next two lines are your delimiter and printf statement. So your delimiter of your for loop and printf statement is available in this, and the last two statements are nothing but your closing delimiter and closing delimiter. Now this is how the program is going to be resided in your main memory. As I am saying that your page size is equal to what? Only 2 lines of code, if you assume like that. But what a user is thinking that I have written only one function only. What is that function? The function name is a main, and I am seeing that from this particular part to this particular part, it has to be loaded into your memory as a single program. But what are we doing here? We are trying to split your program according to the size of the page, which is decided by your MAR. MAR is nothing but what? Memory address register. According to that, you're going to split your program into smaller units, and your program becomes a pieces, and these pieces are scattered in your program in your memory. What I mean to say, without having any kind of meaningful links means what? Here here this, the for is being divided. For is available in one particular block and delimiter is available in another particular block. This is the bad view of what? Execution of your particular program. This is a second drawback. First drawback is internal fragmentation in the last block, as we are assuming n by 2, and the second drawback is that you cannot able to how the user is thinking that this particular function has to be executed in a single block, but it is impossible in the case of paging, because paging is a dynamic activity. It all completely depends upon the size of your particular page. So in order to avoid these two problems, there is a requirement of what? Storage of your program into blocks. What is the meaning of a block here? When I am saying this main is a one particular function which must not split, as it is consist of what? Series of statements. These statements must not be divisible. Please understand. When user thinks that these statements must not be divisible and I want to place exactly as like a one alamara or one box, then you cannot use the concept of what? Paging. Therefore, you need to use a concept of blocking memory techniques. That blocking memory technique is nothing but what? A segment. A segment, you see that in cars, if you observe that there are three segments cars are there. One is a lower segment, the other one middle class segment, the other one high level segment. High level segment cars are very costly, and middle level are better, and lower level are cheaper. However, you are having a different kinds of variations in the products in your program is also supposed to have in such a way of execution. What is that? We want to see that smaller blocks and bigger blocks and too much bigger blocks we want to accommodate. So friends, what I want to tell you, a segment is nothing but a flavor, and there may be a consist of different kinds of flavors. Then what do you understand? When you are talking about the segment concept, your memory is also having a segment nature only. What is a segment nature? I said that it may not be a fixed slot as like your paging. If I am saying that paging, all the blocks are supposed to are having a same length without a doubt. Therefore, that's why there is a need of a splitting of your program according to your particular, what I mean to say, page size. But if you are using the concept of a segment concept, your memory is going to be dynamically allocated such that, please understand, paging is a MFT. All of you, please understand. Paging is a MFT. MFT in the sense, don't think that it is a contiguous. MFT in the sense what? It is a fixed. It is a fixed. That means initially your particular memory is going to split fixed into different kinds of pages which are all same sizes. Please understand. But your segmentation, when you are talking, it's not a fixed, it's a variable. Hence, we are calling it as a what? MVT. Please, this is a very important bit. It, Nobody knows. Many of the people may not know about this. But I'm talking a paging is it is a fixed partition scheme. But when you are talking about the MVT, it is a variable line. Based on the function, I'm going to allocate the memory. Otherwise, I'm not going to create any kind of initial partitions. That's why MFT suffers from internal fragmentation and MVT is free from internal fragmentation. So it is free from internal fragmentation as we know. Now you see friends, small segment requested some amount of memory. Then I will allocate as much you required according to the request of the user a small segment. Somebody asked me that I need a bigger memory, so I'm going for medium level blocks. You can. If I'm having that I want a larger size, so you can also accommodate a larger size blocks also. Therefore, the holes which you are created are completely dynamic according to the user's request. We are not depending on your page size. This time we are depending on user request only. So this is based on, please understand, this is based on user request, the memory is allocated. This is based on system. So system based, this is, that means user has to follow system. But here system has to follow users while allocation of memory. So friends, what is exactly now the segmentation? We will see now. So when you are talking a segmentation, many of your programs are going to be loaded as far as blocks concerned. If I am saying that memory is allocated, memory allocation based on blocks. These blocks are dynamic. Please understand. These blocks are dynamic. So we guess that every module is a one block. Every module is a one block. What the user is thinking? User is thinking that, for example, I am saying main function is a one block. Please understand. This is a one block. And you say that some add function, this is a block 2. And some differentiation function, and this I'm saying that this is a block 3. How I want to execute? I want to execute like this. In your C language also there are some mathematical functions are there. Square root is going to be executed as a single entity. Power is going to be executed as a single entity. Your heap block is going to be executed as a single entity. Your stack block is going to be executed as a single entity. Friends, so what I want to tell you, this time onwards, we are going to do allocation of the memory only based on module wise, not based on lines wise. Please understand. While you are talking a lines, it's a paging. While you are talking a blocks or a group of lines, it is a what? Block. You can also call it as a what? Segmentation. Now you see, there are a few important things we are going to see here. So when I'm talking about the segmentation, how your memory is going to be represented here. Now I say your completely main is executed in one block. As I said, main program consists of, as far as the previous program concerned, I'm saying that int I, and there is a for loop, and there is inner braces, and there is a print, and there is a closing delimiter. Entire this is going to be loaded exactly at the same particular place. And if you are saying that I'm having a, for example, a heap block, and you're going to get without splitting, it is going to occupy the memory. When I'm saying that square root function, it is going to occupy the memory. When you are saying that some kind of a stacks, that is going to allocate in the form of blocks. Now we are seeing not in the form of lines, we are seeing in the form of a block. This complete block consists of completion of your program. If your program is having a 200 or 300 lines of a code, I do not want to disturb them. I am trying to keep it in a directly blocks only. but provided that your block, your memory is supposed to have that kind of capacity. You can call it as what? Segment sizes. Now, first of all, let us see some of the important points which are there in segmentation, whatever I spoke so far. What is that? The paging does not allow user's view of execution. So user's view of execution is nothing but module by module we want to place it on the memory. But paging is going to do what? Your entire module is split into smaller pieces according to size of your pages only. And next one is that paging never thinks that what is happening inside. It may consist some loops, some are may consist outside and some are may consist in some other pages. So loop also must not able to splits. So all loops we want to put it in a what? Single block. Therefore, to achieve user view of a memory, then there is a requirement of what? Segmentation. And one more important point I highlighted here, that this is the point. What is that? Internal fragmentation also can be eliminated, which is occurred in the last page. And the next important point is that if I am saying that I have got, please understand, I have got 200 pages in each process, 200 pages in each process. Likewise, there are 100 processes are there. If you are thinking like that, if there are 100 processes are there, then you need to get 100 page map tables. Please understand, you need to have 100 page map tables, and each page map table is taking care of what? 200 pages entries. Please understand, multiply by your page entry size, then you are going to waste this much of amount of memory of your main memory only towards what? Your page map tables only. Friends, therefore understand, now it is going to store page map tables of this much size. But what the segmentation is telling you? Segmentation is going to tell you that the number of lines which are there in the segment is smaller. For example, I say, please look at this example. I'm saying there are 200 lines of code, and I am saying that block size I am keeping initially. Your segment size is always greater than your page size. If I am saying that block size is equal to almost all 100 lines I can able to store. So therefore, what is going to happen? Simply, I need only what? Two segments only. So therefore, friends, please understand, your number of entries, segmented entries, number of segment entries is nothing but number of segment. As there are two segments are there, now your segment table, very similar to page map table, your segment map table consists of what? Only two entries. One is for segment 0 and one is for segment 1. Therefore, you can allocate very small amount of memory in your main memory towards what? Your segment page table or segment map table. This is a one more advantage. What is that? If you are using a paging, if you are having a concept of many number of processes, and page map table takes a more number of entries because your page size is smaller than your block size, that means segment size. Therefore, instead of having a multiple number of pages, better to you have a concept of what? Less number of pages. That means your pages are combined together as a block. Now I'm going to send them those compressed lines into one block. Therefore, one block consists of many number of entries. That block I am calling as a what? Segment. Now as there are only two segments are there, these two segments are only going to be loaded as your segment map table. So I have segment 0 and I have a segment 1, and this is my segment map table, which consists only what? Two particular entries only. So that is the point, friends. What is that? Please understand. Page map tables are bigger and needed more main memory. So friends, these problems can be avoided. So now we are losing what? Paging. We don't want to follow paging. We are going to follow a concept called what? Segmentation, to avoid those drawbacks, especially extra internal fragmentation And the second one is that what? User point of view execution of blocks. The third point is a what? Instead of having a larger page map tables, I'm following a smaller segment page map tables. Now, what is a segment? It is a group of lines. Very simple. The program is divided into not equal. They are what? Unequal segments. It's not necessary that all the segments are same size. Then again, you are going to have the same problem like paging. But here segments are what? Unequal sizes. Some segments may have a smaller space, and some segment may have a larger space, and some segment may need what I meant to say medium space. So your logical things of the program are these. They may be available on your main memory at different kinds of sizes. So you can have smaller, bigger, and larger. So all the modules need not be the same. They are having a different sizes. So it is going to achieve what? Memory user point of view execution. So the next one is, as I said that the segmentation belongs to MVT, paging is belongs to MFT. Therefore, friends, whenever you talk about the variable size insertion, now I am following first fit and next fit and best fit mechanisms. Don't forget that. So your segments are going to be allocated according to this particular thing. That means what? We are using these methodologies to avoid the memory, and a segmentation and uses MVT, and the segments are protected using a base and limit registers. And the next point is that segments can be swapped in and swapped out. That means if I am not having, for example, I say there is a segment 0 and a segment 1 and a segment 2, three segments are loaded, and there is a one more segment S4 is requesting, and there is no space on your main memory. When there is no space, now I can able to do what? I remove this, and now you can place what? Your segment number 4 as like our previous methodologies. So segments can be swapped in as well as swapped out, and every process maintain a segment table. The segment table consists of, this is a very important question, the segment table consists of mainly what? Few entries. What is that? Your segment number and the base register and the limit register and the offset register. These are the four entries are there in your segment. So this is a very important question. Your maximum segment size is nothing but entire logical address space. Minimum segment size is nothing but one page. So number of entries in your segment table is nothing but number of segments are there in your logical address space. And this is another very important question, that segment deals with the what? Linear address. So what is your effective memory access time? The effective memory access time is a double like your paging only, because I need to maintain, one is a what? Segment map table, the other one is your segmented data. Therefore, data memory access time is a 1 and the segmented memory access time is a 1. Therefore, your effective memory access time is nothing but 2 into memory access time. This is another important question. And what are the advantages of segmentation? So we know no internal fragmentation, chance of what? Modular structure programming, consumes less memory than your page tables. And the next one is that memory reference is easy and protection user view of memory execution. But there is a drawback with segmentation. What is the drawback? We will discuss first of all segmented architecture, then we will see the drawback. You also can guess what is the drawback. I am saying that segment is following MVT, then with MVT there is a one problem. So what is that problem? You need to identify. So anybody who are there on live can able to say this. So what is the process of segmentation? The process of segmentation like this. First CPU generated address S comma D, and S is nothing but number of bits required to represent your segment number. And the next you need to check that your segment size is lesser than limit register or not. If it is satisfied, immediately we are going to do what? Plus operation just by adding your requested number with your base register. So therefore, I'm doing a logical address mapping like this. What is that? The CPU generated. This is your CPU generated. The CPU generated segment ID and a segment request. That means what? Segment requested instruction requested size is 100. So therefore, immediately it verifies in segment map table. Now your segment map table, there are a pool of segments are there. I am requesting for segment number 1 as the CPU is asking. So CPU generated address is in the form of S comma D. S is nothing but what? Segment number, and D is nothing but what? Your segment offset size. As I am requesting 1 here, and your segment offset I am requesting to 100th instruction. Now it points to, so now it is pointing to your segment map table. There it sees that yes, 1 is available, and it takes that 1000 base address value. It also takes that limit address value also. So limit, the size of that particular block is 1000 and the base address is 1. Therefore, what is going to happen? It pulls this limit. It cross checks that your requested number is lesser than to that or not. So I am checking your requested D is lesser than is equal to your limit value. So I am checking D less than your LR. So here LR is nothing but limit register. As far as this, it is retrieval to 1000. Therefore, this condition is also true. If this condition is a false, then it is a trap. So when this condition is a true, then it takes this base address that is nothing but 1000 and you are requesting to 100. So therefore, it gives a 1100, that exact 1100 it is trying to point out. So whatever may be the block, it is exactly at 1100. Now you see this 1100 is in the range of this sentence. What is this? It is in between 1000 and it is in between what, friend? 2000. What is this? This 1000 to 2000, it is meant for what? Texted data. It is meant for texted data which is loaded. What is loaded inside? The loaded is a segmented one. Please understand. So now the segmented one consists of what? Your this number to this number. So this texted data is nothing but your segment number 1. Because segment 0, nothing is there. 0 to 1000, maybe it is allocated to operating system, and remaining we are going to see the remaining. What is that? Segment 2, 4000 to 4500, which is nothing but your data. Segment 3, 8000 to this one. What is that? 8002 plus 1, it is nothing but 9000. So it is loaded into stack. This is a lesser segment than the others. And the next one, segment number 3, done. Segment number 4, 9000 to 1000. It is a plus 1000. It's nothing but a heap. That means it is not compulsion that all the segments are of what? Same sizes. They may be variable sizes also possible. Now, so let us see one important example. What is that important example? This is your segment table as like your previous diagram 0, 1, 2 and 3, and the base register values are given like this. He is asking complete the physical address for a logical address of 0222. That means your CPU generated, please understand, your CPU generated two attributes. One is S, the other one D. So S is nothing but a 0 and D is nothing but 222. Whether this request is a valid or invalid, we want to check. So valid or invalid, we want to check in the sense this will give request to your segment map table only. What the segment map table is going to see, the first argument it is going to see, that is a segment number. So yes, 0th segment is found. That means you are requesting to 0th segment only. If not available, immediately it throws an error. So 0th segment is available. It takes that base address and a limit address also. Limit is nothing but line. I am requesting how much? 222. I will cross check. Your 222 is lesser than is equal to your length. How much it is, friend? Your length is 124. Therefore, we understand your requested is not lesser than to your length of the 0th one. Hence, it is going to be what? Hence, it cannot able to give you any kind of mapping to you. Please understand carefully. So, what did we do here? We did a fewer kinds of validation process. What is the validation process? Understand. So now I'm drawing a validation process here. What is that? So whenever CPU generated an address which is in the form of LA, which consists of S comma D, and first I will point to your page map table only. So this D will go away that side. Now point to page map table. So it checks first of all whether the particular segment map table, the particular segment is available or not. So first we will verify in your first attribute, that is nothing but segment number. If it is identified in your segment map table, let us say S0 you are requesting and you are asking the length also, it is going to give you. The length it is given as 124 only. Its maximum capacity is 124, which means, friends, you understand, in your memory it is taking only 124 bytes, or maybe a kilobytes, or maybe a megabytes. This is reserved only for what? Yes, not. And the remaining are reserved to others. This is 0 to 124 if I am saying. Now you see, so I understand that S0 is available. When S0 is available, and it is going to also give one more value, that is your starting address. If I am saying my starting address is 0, let. Therefore, what happened? First of all, before giving your logical address mapping to physical address mapping, it is going to cross check that your requested size is must be lesser than is equal to your limit register. If it is a lesser, you can able to access the memory by using a base register. If it is not lesser, then it's false. Is yes or no? If it is no, we are accessing somebody's memory, somebody's segment, some other segment. Therefore, if it is yes, then what are we going to do? We add this 0 plus and requested number. That is nothing but what? Your D. Now we are going to access the corresponding block, what you are going to point. But as far as the previous diagram concerned, we understand the requested number is something like you are requesting 222, but my limit register is having only 124, hence you cannot able to access it. Now come to this example. So now this is a fine, all right. Why all right? It is requesting 3 comma triple two. What is a 3 comma triple two? The CPU generated address is a logical address which is asking a 3 comma 222. The first field is a segment number, second field is your segment offset, which is nothing but S comma D only you're asking. First I will check that 3 is available in your segmented base table or not. So as far as, please understand, what is that? Segment 3 we are asking. So segment 3, as far as the previous table concerned, yes, it is available. Its base value is 498. Its length value is 302. Now let us look at the diagram. So whenever it is available, it immediately gets its base address, that is nothing but 498, and it also takes your limit value also. So limit value is 302 and your base value is 498. Please understand, 302 and 498. Therefore, I am going to cross check. You are requesting for triple two. Your triple two is lesser than is equal to your limit value. Yes, it is correct. Therefore, it is taking like this. Take your 498. So I am asking if 498 is my block starting number, and I am requesting a triple two. So 498 triple two is nothing but 800. Exactly, you are trying to access this particular block only. You are accessing this particular block. Please understand, friends, this is how the block starting number is how much? 498, and ending number is a what? And luckily 800 is got closed. So I am accessing the last instruction one, because your block size is from 498 to 800 only. This is how the previous one is a trap, but this is exactly suitable because you are satisfied. What is that? Your D value is lesser than is equal to your limit register value. Now, the other one is segmentation with paging. And now friends, I want to give an example here. Before going into segmentation with paging, please understand. I say this is your memory which consists of some programs. This is a hello program. This is a even numbers program. And this is odd numbers program. And this is Fibonacci series program. Please understand. There are 4 programs and bottom it is reserved to operating system. Now there are some numbers are also available on your physical memory. I say 0 to 99 and this one is from 100 to something like 150 and this one I am saying the next one 151 to something like 199 and this one I am saying 200 to 299 and this one 300 to 310. These are your addresses. Please understand. These are your addresses which is there on your main memory. Now you see how the user is requesting. So CPU generated one address. The address consists of S comma D. Now these are the names. So now I am going to keep some of the blocks here. I say this is a block 0 and this is a block 1 and this is a block 2 and this is block 3. Block 3 is nothing but segment only. It's a block 4. Now I am requesting, see, I want to access even numbers. Even number in the sense you need to look at this only. How CPU is going to execute. So it is going to give you the block number. So 3th block number. I'm going to access even numbers program and some exactly one kind of request I need. So I say you need to tell that what is the base address of it. That's very, very important. So immediately it will cross verify in your segmented map table. So I'm saying, for example, say even number 200 to 299. So I'm going to ask 100 now. Now please observe, your segmented table consists of 2 parts. One part is segment number, the other part is a base value, the other part is a length or a limit value. Now there are 1, 2, 3, 4, 4 user segments are there. Segment 1, segment 2, segment 3, segment 4, segment 2 and segment 3. This is your segment map table. As many segments are there, those many entries are being added in this. Now you see, as I am calling segment 3 only, my focus is on to segment 3. Segment 3, I will tell you that the base address is a starting address. That's nothing but 200 I am sending. And it is asking that length how much you need. I say that I want to go for 100. Now please understand friends. Now I'm going to check before giving you access. I come to know that okay, S3 I found. Second validation is there. What is the second validation? You need to cross check that your asking 100 is lesser than your request is 100. Please understand. Your request is 100 which is lesser than to the corresponding limit. The corresponding limit is also kept as to 100 only. So therefore, what is going to happen? This is satisfied in this case. So when this is satisfied, you are going to access this memory. How? It is going to give you starting number to you. What is the starting number? You are trying to access a 200th address plus you are requesting for what? 100. Therefore, exactly, it try to take you to the block 3. Now you are trying to access what? This particular block. This is how you can able to access a block by block memory with the help of what? Segmentation. The advantage with segmentation is that please understand, Some are having a smaller blocks, some are having a larger blocks. You can have any kind of a sizes. As I said that there is no kind of a restriction as we are using a concept of what? MVT. You will find that all kinds of a flavor of segment, some are smaller, some are longer. Now, please understand, when I am saying paging, when I am saying normal paging is been enhanced to concept of what? Segmentation. Why? I already told you. Two important factors. One is that internal fragmentation, and the other one is that what? It is going to execute MFT fixed. This is a fixed. It's not a dynamic. So we end to segmentation. What is a segmentation? This is internal fragmentation. So segmentation is telling you that no internal fragmentation, and I am not a fixed. It is a what? Variable. Okay, it's fine. And it is also telling you that user point of view execution. All features are there. User point of view execution. All benefits are there with your segmentation. But why still we need one more enhancement? What is that enhancements, friends? This is your last topic or a last which one we are going to use right now. What is that? We are using a segmentation plus paging. That means we are trying to see that the combined features of your paging and combined features of your segmentation together we are using nowadays. What is that? Segmentation with the paging concept. We do variability as well as we do what? Fixed. So why are we doing that? So I will tell you. So what are the drawbacks of segmentation? If I am doing only segmentation, what are the drawbacks? So the first drawback is this. For example, you see, so this is a capacity is 100 kb and this capacity is a 200 kb. Now you see there is a one more block middle. This capacity is a 50 kb. Please understand. Now earlier this is given to S0, this is given to S1, this is given to S2. According to that, the space is been allocated to three different segments. Now S0 got completed. So when S0 got completed, I got back free space 100 kb. Now please understand, S4 requested 101 kb. Now please understand, when I am requesting 101 kb, I cannot able to allocate onto this first one. That means what? That is not that much easy to swap out your particular blocks from one to there. For example, I am suspending this S0. You think in that way also. If I am suspending this S0, I want to keep this S4 onto that. It is not possible. I am able to suspend S0, but I am unable to what? Place it on my particular required memory onto your memory because it is 100 MB only. This is another one. This is the problem with what? Unequal or non-equal splitting. When you do non-equal splitting, then what I mean to say, swap ins and swap outs are taking a much more difficulty. But when you are doing equal splitting, what is going to happen? Any frame or any page can able to place anywhere else. Swap ins and swap outs are very simple. But here swap ins and swap outs are very, very difficult. Why? This is the issue. What is that? I cannot able to keep that much easily swap ins and swap out operation. And the next important point is that, please see. Somehow S0 is completed. I am talking about the second point. Observe carefully. So S0 is completed. So S0 released 100 kb of memory. So S0 released 100 kb of memory. S2 also got completed. So you remove S2 also. It is also got completed. So after remove, you got 50 kb of memory. Please understand. So line by line, if you learn, you will be perfectly alright in segment and paging. So 50 kb is also released. Now Segment 4 requested as like the previous. How much? 101 KB. Now it is not possible. Why it is not possible? Please understand. So I cannot able to allocate 101 KB of memory because you see I do not have that much kind of a partition size because already it is occupied. So I got 100 KB and I got 50 KB back, but I am unable to allocate to 101 KB. Therefore, this leads to a concept of what? External fragmentation. So I said, the paging is going to suffer from internal fragmentation and the segmentation is too much bad, is going to suffer from external fragmentation. So I cannot able to accommodate into this and I cannot able to accommodate into this. Therefore, it is a concept called external fragmentation. This is the second drawback. One is not that much easy to do swap ins and swap out because the chances of what variable sizes. And the second one is that what? External fragmentation. So unequal sizes are not that much easy to do swapping. And the next one is a what? External fragmentation you are going to see, especially in segmentation concept. So in order to avoid this problem, then there is a requirement of what? Segmentation with the what? Paging. So wherever you are unable to do this kind of swap ins and swap outs, so what I'm going to do, that block I'm going to split into smaller parts. Please understand that block. So whatever I say earlier, I said that you have got 100 KB of memory because S not got finished. Please understand, S not got finished, then you got free space of 100 KB. So here also one more process got completed by name S3 and you got free space of 50 KB as per as previous example concept. Now I said that there is a segment 4 is requested. That segment 4 is requested. How much he requested? 101 KB memory. So we are unable to allocate earlier because that much space is not there. But here what I am doing? I am trying to use the paging concept. Therefore, S4 is going to be accommodated up to 100 sizes. Please understand. Up to 100 KB I can accommodate because I am splitting into smaller once again into the pages concept and remaining 1 KB will be allocated into this. This is the beauty of the segmentation with paging. What is that? I can able to load variable sizes and if at all unable to load that variable size, better you split into smaller pages as like your paging concept. Therefore, you don't feel that I am facing external fragmentation there because 100 KB is loaded at one place and 1 KB is loaded another place because I am using the concept of what? Paging. That means splitting your segment into what? Smaller pages is the concept of segmentation with the paging. So we are doing segmentation is nothing but a what? Collection of pages and a page is a fixed size as we learn. So now it is the combination of what? Segmentation and what? Paging. That means paging is applied on your segments. Okay, the minimum segment size is your one page and the maximum segment size is your logical address space. It avoids external fragmentation. Okay friends, so how to do? I will show you. Observe now. Now we are having a two important units of your MMU. Your MMU has two important units. One is a segmentation unit, the other one paging unit. So segmentation unit is going to do divide entire your program into variable number of blocks and still you are unable to load onto your memory due to insufficient memory, then you better immediately do what? Paging concept. Now it is offering to you what? Segmentation and paging together. That's why there is a need of a two important units, segmented unit as well as paged unit. So after that we are trying to access what? Your physical memory. So this is the diagram of that. What is that? The CPU is requested a segmented and its offset S comma D. Please understand. If you are unable to keep this D onto your main memory, then this D is going to further split into what? Pages only. So let me draw this diagram so that you will understand step by step. Please understand. The CPU generated address is in the form of S comma D, and first it is contacting to your segment page map table. Now your segment page map table is going to have a valid entries for your segments. If for example I am requesting segment 0, fine. Then immediately it takes your base value. It also takes its what? Limit value. Both values it is going to take against to your segment 0. So our focus is to this. I requested as 0. Now second step, this is your first step. And the second step, validation required. Your requested size is lesser than is equal to, please understand, your requested size is lesser than is equal to your limit register or what. So we are doing here validation D less than LR. This is your second step. This is a normal segmentation. Normal segmentation means what? If it is yes, then immediately it takes its base value. It takes its base value. Then we are adding this plus D here so that you can able to access your main memory. This is a normal segmentation. But I am doing this time paging. Why we are doing paging? Please understand. We are doing paging such that this D, whatever you are saying, I am unable to allocate onto your main memory. I already shared this particular example. What is that? I am unable to load this particular block because the amount of space is not sufficient. Earlier 101 MB memory we see that. So 101 KB I want to load, but there is 100 KB available and 50 KB available. I cannot able to locate your program exactly one particular position. That's why what I am doing, this 101 KB is nothing but what? Your request is nothing but what? D only. So whenever you are unable to allocate your D onto your main memory, then this D is going to split into what? Pages. Now this is going to split into as usually P comma D, and here you are going to have as usually F comma D. The second part is a paging unit, left part is your segmented unit. Now please understand, this D and this D is as usually same. Now this P will consult as usually what? Page map table. Now this is your page map table. This is not the page map table for all the segments. Please understand. This is the page map table of which segment? Please understand. This is the page map table of only the requested segment only. That's nothing but S now. Likewise, you need to prepare page tables for all the segments. This page map table I am speaking only for the requested segment. That is nothing but yes now. So therefore, here you are having some kind of pages, and the same your memory is also having this time paging concept only. So we are having group of pages here, and you can able to keep your pages anywhere onto your memory like a normal paging. Now I'm going to distribute these pages onto S0 pages onto your main memory. Now your main memory consists of what? P0 I can store there, P1 I can store there, P2 I can store here, P3 I can store here. These are all the pages that belongs to your S segment 0, not others. This is how you can also do the same process with the other segments also. So what I am doing here? There's a fourth step. Please understand, this is the second step, and your third step is that splitting. Split your segment according to the segment size according to the size of the page. So now it is going to split, and this time the pages are loaded into page map table. So you need to do binding here only. This is your fourth step, and you got this value. Finally it is going and talk there, and this is your fifth step. Finally you got a physical address. This is your physical address mapping. So friends, this particular part is a completely left hand side is a segmented unit, and the right hand side is a what? Paging unit. So we are doing segmentation as well as a paging together in order to locate your variable sized blocked pages onto your particular physical memory. Okay friends, that means what? Even if you are unable to allocate your entire block onto main memory, better you split them and try to post them into according to pages. So this is the much more having a advantage such that any kind of a block, as far as a user point of view, I am loading it. If user point of view it is satisfying, system hierarchy also it is satisfying. Therefore, you are trying to load unequal sizes of segments in the form of pages are available in your memory. And the second one is that, please understand, this is one important point. I have used segmentation plus paging. So this is done by segmented unit. This is done by segmented unit of your MMU, memory management unit, and this part is done by your paging unit. So paging unit done, paging concept, segment unit done, segment concept. But you understand this page map table, what I am doing, that you need to keep it only for what? Corresponding segment, not for all the segments. But there is a one important issue here. What is the important issue? Please understand. If I am maintaining paging, come to our previous classes, that's nothing but paging. If I am maintaining a paging, your main memory consists of your equal pages and page map tables, nothing else. If I am using a segmentation, you know what are its pros and cons. I'm not going to revise it. Your main memory consists of what? Not pages. Your main memory consists of what? Segments and a segment map table. Please understand. If I'm combining this and this together, then what is going to happen? You are going to get segmentation plus paging. Then your main memory consists of what? Tell me. Pages of the segments. Pages of segments. And you also required what? Please understand. You also required a segment map table. And you also requires what? Page map tables. Please understand. So these are the three components you need to place in your particular memory. Therefore, here your effective memory access time, please understand, your effective memory access time, 2 into memory access time, one is for paging table and the other one for data. Here segmentation is nothing but what? Same. Your effective memory access time is nothing but what? 2 into memory access time. One is for segment table, one is for segmented data. But if you are using the third concept, then your effective memory access time is going to be vary. Why? See that you are accessing segmented table, you are accessing page map table, you are also accessing what? Pages. Therefore, it is a too much complexity process, but real time it is required. You want to get the benefits of segmentation, then you better use the concept of segmentation and paging, because simple segmentation you cannot satisfy all the way. There may be a chance of external fragmentation, and easy swappings and swap outs are not possible. So this problem you can able to avoid with the help of segmentation plus paging. So so far I did like this. What I did, the segment I am taking and D I am taking. This is what CPU generated logical address to you. This D I am doing a what? Paging activity. This D I am doing a paging activity. Therefore, this is your page map table. So you are going to get once again P comma D here, please understand. And here you are going to have a what? F comma D here. Understand friends carefully. You will get a confuse here only. And now finally we are trying to access your main memory. Those who are listening for the first time, understand carefully. So I am not worrying about the segment, please understand. I am not bothering about segment. Our idea is only D. The entire segment I am unable to place onto your main memory. Then that segment 0 or 1, whatever it may be, I am trying to split into smaller units. That's why our target is this D only. Therefore, this D is going to divide into two parts. One part your page numbers, the other part is what? page offset. So I will tell you the real time one. Observe carefully. Now I'm saying your logical address is 32 bits. This is a standard textbook example. I'm saying that, please understand, segment size is equal to 12 bits. And I'm saying what is how you can able to hierarchy. And I say page size is equal to, so let us say a bit bigger. I'm saying segment size is equal to something like 20 bits. Now I'm taking page size is equal to 12 bits. Please understand, friends. Now, is it required segmentation plus paging, or only segmentation is sufficient? So we need to think logically. So this is the example. He is asking, can I use only segmentation, or do I need segmentation with placing or not? The solution is coming like this. The solution is the CPU generated address, which consists of two parts, S comma D. S is nothing but number of bits for segment representation numbers, and D is nothing but the segment size, 10 lines or 20 lines or 30 lines code. Now therefore your logical address what you are speaking is a 32 bits now. So when you are saying that it is a 32 bit, now what is going to happen? This 32 bit it is taking. So in this 32 bit, 20 bits are for segment size. That means this D consists of 20 bits, and the remaining 12 bits are for what? Your segment numbers only. Therefore, you understand, can I directly use a segmentation? No. Please understand. We cannot use a segmentation because, please understand, because your segment size is greater than your page size. So therefore I cannot able to fit this 20 bits onto your particular 12 bits slots. Therefore 100% there is a requirement of what? Segmentation plus paging together you need to use it. Now let me go for one more example. So problematic I am solving, observe carefully. So I am doing here, this is your logical address which consists of S and D, that is of 32 bits. I am not saying any kind of information, and here this is said that 20 bits and this is said that 12 bits. I can handle two questions from this. First question, number of segments, first question, and the second question, size of a segment, size of each segment. That's very important. Size of each segment. Now your number of segments you all know that is nothing but 2 power 12 segments, and the size of segment is nothing but 2 power 20. So friends, if I give you one more, that is that page entry size, here page is nothing but segment entry size only. Segment entry size is equal to 4 bytes. What is segment table size? Because you also need to maintain this. Therefore, what is going to happen? Your segment table size is nothing but number of segments into your segment entry size. That is 2 power 12 into your 4 byte, which is nothing but 2 power 14 bytes. So friends, you need to keep this one into your main memory. Please understand. You need to keep this 2 power 14 bytes into your main memory. You also need to keep all your 2 power 12 segments. Please understand. You need to keep 2 power 12 segments onto your main memory. You also need to keep this segment table on your main memory. This is the one question. Now let us see second question like this. This time I'm combining segmentation with paging. Why? Because I'm mixing both the one. I'm saying let logical address is equal to 32 bits and page size, I am using now paging concept. Page size is equal to 12 bits. I am also giving you segment size. That means I am also using segment together. So segment size is a 20 bits and page entry size is equal to 4 bytes. Segment entry size is equal to 4 bytes. Now we want to answer what is your segment table size and page map table size. The solution is like this. First question, number of segments. You know number of segments by taking this diagram. There are two values s comma d. So s is nothing but 32-bit he mentioned, 20 bits for segment size. So remaining 12 bits for what? Your segment size. Therefore, observe friends, number of segments are 2 power 12, which is nothing but 4096 segments. These many segments you got, and he is asking that number of pages. Number of pages are nothing but, now we need to do what? The segments must be split into pages. Before that, let us see what is your segment size here. What is your segment size? Let me write. Your segment size is a dedicated 20 bits there. Therefore, 2 power 20, which is nothing but 1 megabyte segment this is. Each segment size and which is having 4096 segments, you have to make this much segment size is there. Now, but unfortunately, I am unable to allocate memory to complete your 1 MB. I do not have 1 MB slots. Please understand. When you do not have 1 MB slots, this is not equal to 1 MB and this is not equal to 1 MB. Therefore, I cannot use directly segmentation. I need to use now a concept called what? That segment has to split into smaller pages. So what I am going to do? I am doing now. So number of pages for each segment. Number of pages are nothing but this 20 I am unable to allocate. Please understand. This 20 I am unable to allocate. Therefore, this 20 is going to split into what? Paging. Now, your paging consists of P comma D. Here also you are having a physical address and it is consisting of what? F comma D. So here D and D is the same. He said that page size is 12 bytes. I can happily store 12 bytes here. I can happily keep 12 bytes here. And remaining, please understand, I am doing only process for this 20 bits only. Please understand. Therefore, what is going to happen? This 8 are nothing but what? Your single segment is divided into 2 power 8 portions. Please understand. So, your memory is going to consist of what? Please observe. Your memory is going to consist of what? For your single segment 0, I am looking at 256 pages. Please understand, I am looking for 0th page to 251st page because 2 for 8 is nothing but 256 only. Therefore, this is only for segment 0. So I am saying number of pages for each segment, it may be 0 or 1, it may be 2, which is nothing but what? Please see, this is the important point. 2 power 8 pages, which is nothing but 256 pages, each of worth of what? 12. Now friends, understand, now I can able to store what? Your page map table into that, because you divided in such a way that your page map table is going to occupy exactly into your main memory. So therefore, if not, then you supposed to do multi-level paging as usually. If at all you are unable to keep your page map table into that, you're supposed to do multi-level paging there. So what is your page map table size? That's our last question. Your page map table size is nothing but number of pages are 2 power 8. Please let me continue that. So what is your page map table size? page map table size is equal to number of pages into page entry size. Number of pages we got 2 power 8. Page entry size is at 4 bytes, which is the 2 power 10 bytes. Exactly, I can able to locate onto your page, because your page size is how much, friends? 12 bits. Please understand. Your page size is at 12 bits. I can able to locate 2 power 10 exactly, because 2 power 10 lesser than is equal to your 2 power 12. I can able to accomplish. First, so I got the answer. What is that? When you are unable to allocate entire segment, better you allocate into what? Small portions called as what? Pages. But there is another issue. What is that another issue? What is the segment table size? Please understand. What is the segment table size? Segment table size is nothing but, we have solved this issue. Number of segments into segment entry size. So number of segments, how many you got? Please come to the point. Number of segments you got 2 power 12. So 2 power 12 into segment entry size 4 bytes, which is nothing but 2 power 14, is greater than your page size, because you need to keep it in page also. Therefore 2 power 14 is greater than your 2 power 12. What is required now? You need to use a what? Paging for your what? Paging for your segmentation. So what I am doing, I will do multi-level segmentation. Multi-level segmentation I am doing, because I am unable to keep my segment table size. Paging table size I kept, but I am unable to keep my segment table size. Now final diagram, understand carefully. Please listen carefully. Dhyan de suno. Now I am telling you, your CPU raised S comma D. Please understand. If D unable to locate, if D unable to locate onto your memory, what I am doing? Take this D out, split it in the form of pages. P comma D. So I am targeting this D only. Please understand. This D I am doing a paging. I am doing a paging only for offset, segment offset. Now you have to consult your as usually page map table. Now this will give you a physical address mapping, which is F comma D, and here to here we have a situation. Then finally you can able to contact your main memory, reminding you. But now problem is this side. What is that? If this S, if segment table is too large, segment table is too large, that means you are unable to accommodate there, that your segment table becomes a huge. And why to allocate that much memory to the segment map table? Therefore there is a requirement of what? Splitting it, like a multi-level segmentation I am doing. So what I am doing this time, I am targeting yes. This yes is going to split into according to your what? Page table entries. Therefore this is a P1 and this is a what? P2. What is a P1? First outer level. Please understand. This P1 is nothing but what? Outer level. This P2 is nothing but a what? Inner level. So I'm doing now two different parts. One is outer level, one is inner level. Outer level consists inner level entries. Therefore, you need not store entire your segment page table into your memory. You can store only for what? All outer pages and one inner page. Please understand. You need to locate onto your memory all outer pages on only what? Inner page only. So instead of keeping entire your segment page map table, I'm trying to what? Save your memory. How I am going to save? Please understand. I say the example is, so number of entries in segment is understand. How many entries you can able to have in a segment to do what? Multi-level segmentation. I am doing multi-level segmentation, friends. Before you want to do multi-level segmentation, first you need to come to the first step. What is that? Number of entries in your segment, which is nothing but segment size divided by segment entry size. Same like multi-level paging only. There also page size by page entry size. Your segment size is given earlier is given with 20 bits. So 20 bits and your segment entry size is your 4 bytes. So how many entries I can able to load here? That is nothing but 2 power 20 by 2 power 2. I can able to load how much? 2 power 18 entries. Now you see 2 power 18 entries you can able to represent in a particular segment table. But our concentration is that left side value, not the right side value. Left side value is what? Yes. So how many bits are there? Please observe. Left side value, how many bits are there? Your left side value means I am targeting your S. So how many bits are there for your S? Please look at the previous example. Your S is nothing but number of segments which consist of what? 12, 2 power 12. That's our concentration. Because of the 2 power 12 only, I am unable to locate onto your particular single slot. So what I am trying to do this time, your S is going to split. So number of entries in segmented table, segmented page map table. I am doing a what? Multi-level segmentation there. Therefore, you are having 2 power 12 entries divided by your segment entry size is 2 power 2, which is nothing but 4 bytes. So you require 2 power 10 entries. Please observe carefully. You require 2 power 10 entries. So friends, your S, which I am telling you, I am targeting about S only. D is already left out. S I am targeting. Your S is earlier given into what? 12 bits. These 12 bits are divided into two parts. One is inner. How many maximum you can keep? 10. Cut it 10. And remaining goes to outer. So outer how many? So total 12. 10 I have given to inner and 2 is for what? Outer. Bus. You got. This is what? Page table of a segment. Page table of a segment. And this is a what? Outer page table. So now you tell me friends, what is the memory size now it is going to occupy? Earlier it is going to occupy, as far as previous example concerned, that 2 power 14 bytes is greater than your 2 power 12 bytes. That's why I am unable to load your segment. Now we are trying to decrease to how much you try to decrease. Please understand, which is nothing but now your outer table consists of what? Only 2 power 2 entries are nothing but 4 entries. And to each entry you are having a what? Inner page tables. How many inner page table? That is a 2 power 10 entries are there. This is the first. This is the first one. This is the second one. This is the third one. This is the fourth one. So here, whatever entry you find, to that entry we are having a innermost entries. We are having innermost entries. So this is a 2 power 10 entries are there. 2 power 10 entries are there. 2 power 10 entries are there. Now tell me friends, what is the segment? This page map table sizes. So this page map table size and this page map table size together how much? It's very simple. How many entries are there in this? 2 power 2 into 4 bytes plus in this how many entries are there? Don't say that it is almost all. We are going to take whenever you are calling for one segment only, that segment page tables will be loaded. Remaining are going to be what? Not considered. So 2 power 10. So we got 2 power 10 into how much friends? 4 bytes. So inner page table is a 2 power 10 into 4 bytes. Outer segment table is a 2 power 2 into 4 bytes. 2 power 2, 4 into 4, it is nothing but 16 bytes plus 2 power 10 into 4 bytes, it is nothing but what? 12 KB. See how much it is got reduced your segmented page table. This is a wonderful scenario. If you really understood, you will understand wonderful scenario segmented with paging. Earlier, yes, unable to load, a segment table unable to load because you are having a much more than your page size, but now I can able to reduce it. So how much I reduced? 16 bytes plus 12 KB I reduced. Okay, friends. So this is how you can able to see a concept of what I mean to say, how you can able to do segmentation to your S value. But in the first case, there are two cases I said. One case, how to do segment to D. Please understand how to do paging to D. This is the first case. Why are we doing this paging? Because your segment completely unable to load onto your main memory the entire size. Therefore, you are trying to split into smaller blocks. Second case. What is the second case? Yes. This yes segment table size entirely I am unable to do. Therefore, what I am doing? I am doing a multi-level segmentation. What is a multi-level segmentation? Take all the bits how many you want and split according to yourself. Therefore, you are going to save the space in which you are going to send your segment map table. Therefore, how to do? I did two level translation I did. This is the two-level translation. First outer page, then it contact inner page, then it contact what? Exactly the required pages. That's it, friends. This is how to do a concept of what? Segmentation with the paging. So from this we can able to find number of pages, number of segments, and how many levels you need. For example, last question I want to keep like this. This is your last question. You will better understand. I say 60 bits it is. So in this 60 bits, he is saying S is equal to 20 bits. Let us take more. S is equal to 35 bits we will take. Number of segments is equal to 35 bits. And the segment size which you are talking, segment size is equal to 25 bits. And he said that page size is equal to 12 KB. And page entry size E is equal to 4 bytes. And the next one is segment entry size is equal to 4 bytes. So how many levels of segmentation you are doing and how many levels of paging you are doing? These are the two questions. How many levels of segmentation? I am doing a paging in segmentation. That's what. How many levels of segmentation? And the second question is that how many levels of paging you are doing? So one is for left hand side paging, the other one is for right hand side attribute paging. So this is for yes, this is for D. So it's very simple. So let me answer this question. So take your 60 bits now. So very good question this is. So I'm taking your 60 bits logical address, which is having a two parts. One is S, one is D. Segment number of segments, segment size. It is a 25 bits. It is 35 bits. Okay, friends. Now he is asking number of levels only. First of all, number of entries in pages. Number of entries in pages. We know multi-level paging. I am doing a multi-level paging now. So what is a multi-level paging? Your page size divided by page entry size, which is nothing but page size already I have given 12 kilobytes, 4 bytes. 12 KB by 4 KB, which is nothing but you can able to keep 2 power 10 entries. So this D, now I am finding number of levels. to paging. So you require 25 bits. You cannot keep it on this 10 bits. 2 power 10. 2 power 25, you cannot keep it in 2 power 10. Therefore, what is required? There is a requirement of what? Paging. So how to do paging? We already know. So this is going to divide into first 10, the next 10, the next 5. So 3 levels I did. 3 levels. I'm talking about this D only. 3 levels I did. And all this last we have your D, small d. This is what I am talking, P comma D. So your D is how much? Your page size is given how much? 12. So now this is your what? A logical address of your, please understand, of your 25 bits. Now you see, I'm doing number of levels to your LHS, that is a segments, number of translations. Number of translations to segments. So you need to take a one more equation. What is that? Your segmented bits divided by your segmented entry size, which is nothing but 2 power 35 by 2 power 4, 2 power 2, 4 bytes now, 2 power 2. So we are going to get almost all 2 power 33. So you say that your page size is 12. Therefore, how many entries you can able to keep? Those many you can able to position it here. So those many you can able to position it by taking number of translations you are doing. Based on that, you can able to do. So in that case, we come to know that how many levels of paging we got, those many levels. So that's it, friends. So you practice more on this, so you are going to get a confidence. Two things I said. One is segment side translation. The other one, segment size translation. So paging we are doing separately, and this paging in segmentation we are doing separately. So tomorrow we are going to do the quiz on memory management. So tomorrow we are going to do quiz on memory management. Don't miss all the 10 topics which I said, starting from MFT, MVT to end of segmentation and segmentation plus paging. So you please attend this quiz on memory management and have a good grip on that. We will meet in the tomorrow session. Thank you very much.